Hello, in this lecture we will find out the diameter of the semicircle. In the drawing we have a semicircle. AB is the diameter of this semicircle, and we also know that AD equals to 7 units, chord DC equals to 15 units, and chord DB equals to 15 units, and we want to find out the size of AB, that is the diameter of this semicircle. So first of all, we will make a construction. We will join points D and B together by a straight line. So actually angle ADB, that is the peripheral angle, is a right angle. According to rule number 1, that states that peripheral angle that rests on the diameter of a circle is equal to 90 degrees. So again I will write rule number 1. Rule number 1 states that peripheral angle resting on the diameter of the circle is equal to 90 degrees. I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle, it can be circle or semicircle, peripheral angle resting on the diameter of the circle is equal to 90 degrees. Okay, so actually the peripheral angle ADB rests on AB, that is defined as the diameter of this semicircle. Therefore, according to rule number 1, angle ADB is a right angle, that is to say it equals to 90 degrees. Okay, so here we can write that angle ADB rests on AB, that is the diameter of the semicircle, diameter of the semicircle, therefore angle ADB equals to 90 degrees according to rule number 1. Okay, so I'll read the things that I wrote. Peripheral angle ADB rests on AB, that is the diameter of the semicircle. Therefore, angle ADB equals to 90 degrees according to rule number 1. So in the next step we will connect together points in the next step. We will define the center of this semicircle as point O. Again, point O is the center of this semicircle, this point, and then we will connect together points O and C by a straight line, and we will also connect together points O and D by a straight line. Okay, actually OC is the radius of this semicircle because it starts from the center of the circle and ends at point C, that is a point on the circle itself, on the semicircle itself, and also OD is also the radius of this semicircle because it starts from the center of the circle and ends at point D, that is a point on the circle itself. Therefore, OD is the radius of this semicircle. We will mark the radius as R, abbreviation for radius, and the same thing is about OB. OB starts from the center of the circle and ends at point B, that is a point on the circle itself. Therefore, OB is the radius of the circle, and also OA is also the radius of this semicircle because it starts from the center of the circle and ends at point A, that is a point on the circle itself. Okay, so in the next step we will focus on triangles OCD and triangle OCB. So we will focus on the green triangle, triangle OCD, and we will also focus on triangle OCB, that is the orange triangle. Okay, so we will focus on the orange triangle and on the green triangle. So in triangles DOC, that is the green triangle, and triangle OCB, that is the orange triangle, we know that side DC of the green triangle is equal to side CB of the orange triangle. Both of those two sides are equal to 15 units. It is given us in the question. Okay, so on triangles DOC and triangle OCB, side DC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units in size, and we also know that side DO of the green triangle is equal to side OB of the orange triangle, both those two sides are the radiuses of this semicircle. So DO equals to OB equals to R, and also OC is a common side. It belongs both to the green triangle DOC, and to orange triangle OCB. So OC equals to OC. It is a common side. Okay. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle is congruent to the orange triangle. Therefore, triangle ODC is congruent to triangle OCB, that is the orange triangle, according to the rule side, side, side. According to side, side, side rule. So, I'll read again the things that I wrote. Therefore, triangle ODC is congruent to triangle OCB according to side, side, side rule. So side, side, side rule states that if you prove that all the sides of one triangle are equal to all the sides of another triangle, then those two triangles will be congruent to each other. Okay? So, from the fact that the green triangle is congruent to the orange triangle, we can deduce that angle DCO, this angle, is equal to angle OCB, to this angle. Okay, angle DCO on the green triangle is equal to angle DCB in the orange triangle. Okay, again, angle DCO in the green triangle is equal to angle DCB in the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, the green triangle is congruent to the orange triangle, therefore the corresponding angles, angle DCO and angle OCB, are equal to each other. And if we define angle DCO as alpha, then angle OCB will be also equal to alpha. Okay, so angle DCO equals to angle DCB equals to alpha. Okay, so in the next step we will focus on triangle DCB, this triangle. So in triangle DCB, we know that side DC of triangle DCB is equal to side CB. of triangle DCB. DC equals to CB. Both those two sides are equal to 15 units. It is given us in the question. Therefore, we have rule 2. Rule number 2 states that in front of equal sides in the triangles, in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually in triangle DCB, we have two sides that are equal to each other, and in front side BC we have angle BTC, and in front of this side BC we have angle DBC, and according to rule number 3, those two angles that are located in front of equal sides are also equal between them. Therefore, this angle CDB is equal to angle DBC. According to rule number 2. Okay? Again, in triangle DCB, angle CDB equals to angle DBC, according to rule number 2 that states that in front of equal sides in the triangles there are equal angles. Okay? And if we define angle CDB as theta, then angle DBC also will be equal to theta, because those two angles are equal to each other. Okay? So angles CDB and BDC are both equal to theta. Okay? In the next step we will define this point as point E. And we will focus on two triangles, on triangle CDE and triangle CEB. Okay, we will focus on triangle CDE and triangle CEB, on those two triangles. We know that side CD of triangle CDE is equal to side CB of triangle CEB. Both of those two sides are equal to 15 units. We also have here a common side. CE is a common side because CE belongs to the green triangle, triangle CED, and CE also belongs to the orange triangle, triangle ECB. So CE equals to CE. It is a common side. It belongs to both triangles. Common side. And those two angles are also equal to each other. Both of those two angles are equal to alpha. So angle DCE in the green triangle is equal to angle ECB in the orange triangle. Both those two angles are equal to alpha. So we actually proved that two sides and the angle included, and the included angle alpha of the green triangle are equal to two sides and the included angle alpha of the orange triangle. Therefore, the green triangle, triangle DEC, is congruent to triangle ECB according to side angle side rule. Okay, so I'll read the things that I wrote again. Therefore, triangle, the green triangle, triangle DEC is congruent to triangle ECB according to side angle side rule. I will repeat the side angle side rule. If you prove that two sides and the included angle of one triangle is equal to two sides and the included angle of the other triangle, then you actually proved that those two triangles congruent to each other. Okay? And from the fact that those two triangles congruent to each other, the green triangle is congruent to the orange triangle, we can deduce that this angle, angle DEC of the green triangle, is equal to angle BEC of the orange triangle. Again, those two angles are equal to each other. Angle DEC is equal, angle DEC on the green triangle is equal to angle BEC on the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so those two angles are equal to each other. So actually, if we define this angle as x, then this angle that equals to this angle also will be equal to x. Okay? Those two angles are equal to each other, therefore if this angle is x, then this angle also must be equal to x. Okay? now we'll focus on angle DEB. Angle DEB first of all, we know that DB is a straight line because in the beginning of the lecture we made a construction. We connected together points D and B by a straight line. Therefore, DB is a straight line, or chord DB is a straight line. Chord DB is a straight line. Again, chord DB is a straight line because we constructed it like that. We connected together points B and D by a straight line. Therefore, chord DB is a straight line. And we know that the sum of the angles along a straight line is one side of a straight line. In the upper side of a straight line at a certain point equals to 180 degrees. So this angle equals to 180 degrees. Okay, this angle equals to 180 degrees, or in other words, angle DEB is equal to 180 degrees from one side angle DEB equals to 180 degrees from one side, but from the other side the size of angle DEB is x plus x. Angle DEB equals also to 2x. Okay? So, from this equality, we can deduce that 2x equals to 180 degrees. And here we can divide this equality by 2 and we will get that x equals to 90 degrees. So we found out that the size of angle x is 90 degrees. So we can substitute x by 90 degrees. We have two angles that are equal to x, so we have two angles that are right angles. So angle DEC is a right angle, it equals to 90 degrees, and also angle BEC is a right angle, it equals to 90 degrees. So we have here two right angles. Okay? So in the next step, we will focus on chord OC. Chord OC is the radius of this semicircle. Okay, chord OC is the radius of the semicircle because of the fact that it starts from the center of the circle and ends at point C, that is a point of the circle itself. Therefore, OC is the radius of this circle, of the semicircle, and because of the fact that OC is the radius of this semicircle, it must be a straight line. OC as radius must be a straight line. So OC is a straight line. Chord OC is a straight line. Okay, chord OC is a straight line. And again, we will focus on the left side of the straight line OC. At point A, the sum of the angles is 180 degrees. Again, on the left side of the straight line OC, at point E, the sum of the angles is 180 degrees. That is to say, this angle that is 90 degrees plus this angle that is actually angle OEB. Angle OEB must be equal to 180 degrees because of the fact that at one side of a straight line, at a certain point, the sum of the angles is 180 degrees. Again, along a straight line, if we focus only at one side, and in this example we focus on the left side of the straight line OC, at a certain point, at point E, the sum of the angles is equal to 180 degrees, and the sum of the angles at this side is 90 degrees plus angle OEB. It must be equal to 180 degrees. So we got this equality that states that 90 degrees plus angle OEB equals to 180 degrees. So here we can subtract 90 degrees from this equality, and we will get that the value of angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. So we actually found out that this angle is a right angle. It equals to 90 degrees. Okay? So actually around point E we have 3 right angles. Okay? Around point E, I will write it down, around point E we have 3 right angles. And the sum of 3 right angles is actually 90 degrees times 3 is 270 degrees. Okay? And the sum of them is 270 degrees. I read again the things that I wrote. Around point E we have 3 right angles, that the sum of them is 90 degrees times 3 is 270 degrees. And we have rule number 3 that states that the sum of the angles around a point is equal to 360 degrees. I will read rule number 3 again. Rule number 3 states that the sum of the angles around the point is equal to 360 degrees. So from rule number 3 we can deduce that the sum of the angles around point E must be equal to 360 degrees. Okay, so if you focus on point E, the sum of its angles must be equal to 360 degrees. Okay, and we will define the size of the fourth angle, this angle, as y. So we can create the statement that states that the sum of the angles around point E is 360 degrees. Okay, the sum of these angles, these three right angles, is 270 degrees, plus the size of the fourth angle, that is y, must be equal to 360 degrees, according to rule number 3 that states that the sum of the angles around the point is 360 degrees. So we created the equality that states that the sum of the angles around point E is 360 degrees, and the sum of the angles around point E is three angles that are right angles, that the sum of them is 90 degrees times 3 is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees. So here we can subtract 270 degrees from this equality, and we will get that the size of angle y, the fourth angle, is 360 degrees minus 270 degrees is 90 degrees. Okay, so angle y equals to 90 degrees. So we found out that all the angles around point E are right angles. Okay, all the angles around point E are right angles. So in the next step, we will focus on two triangles, on triangle ADB, the big triangle, and on the small triangle, triangle OEB. So I will draw again those two triangles. So I do again triangle ADB, the big triangle, and triangle EOB. Those two angles are right angles. Both of them equals to 90 degrees. Therefore, they are equal to each other. So angle ADB, is equal to angle OEB, angle OEB. Both of those two angles are equal to 90 degrees. Those two angles are equal to each other. And also we have here a common angle. Angle B belongs to the small triangle, triangle OEB, and angle B also belongs to the big triangle, triangle ADB. Therefore, angle B is a common angle equals to angle B, because it belongs to both triangles. And the third angle, angle BAD, this angle also equals to angle BOE, this angle. Okay, angle DAB is equal to angle BOE. Those two angles are equal to each other according to the third angle theorem. Third angle theorem or third angle rule. Third angle theorem or rule. Okay, so those two angles are equal to each other according to third angle theorem. Actually, the third angle theorem or third angle rule states that if two triangles are equal between them in two angles, then the third pair of angles of those two triangles must also be equal to each other, because the third angle is complementary to 180 degrees. Okay, if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles also must be equal in those two triangles according to third angle theorem, because the third angle is complementary to 180 degrees. So actually we proved that that all the angles in the big triangle, triangle ADB, are equal to all the angles of triangle OEB. Therefore, we actually proved that those two triangles, triangle ADB, is similar to triangle OEB. Okay, triangle ADB, the big triangle, is similar to triangle, the small triangle, triangle OEB. OEB according to angle rule. According to angle rule. Again, the big triangle, triangle ADB, is similar to the small triangle, triangle OEB, according to angle rule. Whenever you prove that three angles of one triangle are equal to three angles of another triangle, then those two triangles are similar to each other according to angle rule. So from this similarity between those two triangles, the following relationship is true in these two similar triangles. The relationship between the sides of those two similar triangles is that OB, the side of the small triangle, over AB, the side of the big triangle, is equal to OE, the side of the small triangle, over AD. Okay, the following relationship is true in these two similar triangles, that OB over AB equals to OE equals to OE over AD. But what is the value of OB? The value of OB is R. And what is the value of AB? AB, it is given us in the question that AB is the diameter of the semicircle, and as the diameter, because it is the diameter of the semicircle, it equals to R plus R, that is 2R. It equals to 2 times the radius of this semicircle, all equals to OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total we got that R over 2R equals to OE over 7. Okay? R over R is 1, so R is cancelled. It equals to OE over 7. So here, in this side of the equality, we have left with 1 over 2. 1 over 2 is equal to OE over 7. So here we will multiply this equality by 7 in order to get the value of OE. Okay? We will get that OE equals to 7 over 2 units. We found out that OE this line segment is equals to 7 over 2 units. So I write it here. OE equals to 7 over 2 units. And what is the value of OC? OC, the value of OC is actually OC equals to what is the value of OE? What is the value of EC? What is the value of EC? We've already found out that OE equals to 7 over 2 units. Now we want to find out the value of EC. What is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. Okay? EC equals to OC minus OE. Again, EC equals to OC minus OE. So EC equals to OC is the radius of this semicircle. It equals to R because it starts from the center of the semicircle and ends at point C, that is a point on the semicircle itself. Therefore, OC is the radius of this semicircle. And what is the value of OE? The value of OE, we have already found out that the value of OE is 7 over 2. So, in total, we got that EC equals to R minus 7 over 2 units. So here we can write down that EC equals to R minus 7 over 2 units. Okay, that is the value of EC, and this is the value of OE. Okay, So in the next step, we'll focus on two right triangles. On triangle, the right triangle, or triangle CEB is a right triangle because angle CEB is a right angle. Okay, triangle CEB is a right triangle, and triangle OEB is also a right triangle. Okay, triangles CEB and triangle OEB are right triangles. Actually, triangle OEB is a right triangle because of the fact that angle OEB is a right angle. So we have here two triangles in the orange color that are right triangles. And we also know that side EB is a common side. It belongs to both right triangles. Side EB belongs to the right triangle OEB, and side EB belongs also to the right triangle, triangle CEB. So we can write the equality that EB squared equals to EB squared. We write down this equality that EB squared equals to EB squared. EB squared equals to EB squared. We have 2 times EB squared. In the first EB squared, we will relate to these right triangles. In this right triangle, EB squared equals to OB squared minus OE squared. OB squared minus OE squared. And the second EB squared is related to this right triangle, the right triangle, triangle CEB. Here EB squared in this right triangle CEB, EB squared equals to CB squared minus EC squared. CB squared minus EC squared. Okay, so in total we got this equality that OB squared minus OE squared equals to CB squared. Again, OB squared minus OE squared equals to CB squared minus EC squared. But what is the value of OB? OB equals to R. So OB squared is R squared minus OE squared. What is the value of OE? OE equals to 7 over 2. So OE squared is 7 over 2 squared. That is actually 49 over 4 equals to CB squared. What is the value of CB? CB equals to 15 units. So CB squared is 15 squared, that is 225 minus EC squared. What is the value of EC? EC equals to R minus 7 over 2. R minus 7 over 2, and EC squared is R minus over 2 squared. So in total we got that R squared minus 49 over 4 equals to 225 minus R minus 7 over 2 squared. So here we will open the brackets we will calculate the value of r minus 7 over 2 square, and we will get that r square minus 49 over 4 equals to 225 minus r minus 7 over 2 square is r square plus 7 over 2 square is 49 over 4 minus 2 times r times 7 over 2. Okay, so here we have 2 over 2 is 1, so 2 is cancelled. And here we will open the brackets. We will get that r square minus 49 over 4 equals to 225 minus r square minus 49 over 4, 49 over 4 minus plus 7r. So in total we got this equality that r square minus 49 over 4 equals to 225 minus r square minus 49 over 4 plus 7r. Here we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we can cancel 49 over 4. And so after we cancel 49 over 4, we will subtract 7, we will add to this equality r square. R square plus r square is 2r square. 2r square equals to 225 plus 7r. Okay, so here we will substitute 225 and 7r from this equality, and we will get that 2r square minus 7r minus 225 equals to 0. So here we have a quadratic equation The coefficients of this quadratic equation are a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, and actually the variable of this equality is of this quadratic equation is r, we actually have the general formula for a quadratic equation. That ax squared plus bx plus c equals to 0. That is the general formula for a quadratic equation. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find out the value of x by a special formula that states that x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a, when a, b, and c are the coefficients of this quadratic equation and x is the variable of the quadratic equation. So we have our specific quadratic equation that states that 2r squared minus 7r minus 225 equals to 0. So here actually the variable of this quadratic equation is r, so x equals to r, a equals to 2, b equals to minus 7, and c equals to minus 225. So the only thing that is left is to, in order to find out the value of r, is to substitute x by r, a by 2, b by minus 7, and c by 225. So we will do it now, and we will get that x is r, so r equals to minus b, b equals to minus 7, so minus b is minus minus 7, that is plus 7, plus minus root of the root of b squared is minus 7 squared, that is 49, minus 4 times a times c. 4 times a is 4 times 2, that is minus 8, times c is minus 225, over 2 times a is 2, so 2 times 2 is 4. So in total we got that r equals to 7 plus minus root of 49 minus 4 times 225 is 1800. So I write it down. We got that r equals to 7 plus minus root of 49 plus 1800 over 4, or r equals to 7 plus minus 1800 plus 49 is 1849, so it is the root of 1849 over 4. So here we will have two solutions. First of all, the root of 1844 and 1849 is 43, so r equals to 7 plus minus 43 over 4. So here we will have two solutions. The first solution is that R equals to 7 plus 43 over 4. 43 plus 7 is 50. 50 over 4 is 12.5. So R equals to 12.5 units according to the first solution to the quadratic equation, but we have also a second solution. The second solution to the quadratic equation is R equals to 7 minus 43 over 4. 7 minus 43 is minus 36 over 4. 36 over 4 is minus 9. So we got that R equals to minus 9. R equals to minus 9. R is the radius of the semicircle and it must be a positive number. Therefore, R equals to minus 9 is incorrect answer. We will cancel this possibility and we left only with the possibility that R equals to 12.5 units. So the diameter of the semicircle that is actually equals to AB will be equal to 2 times R, and R is 12.5, so 2 times 12.5 is actually 25. So we got that the diameter of the semicircle that is also AB is equal to 25 units. Okay, the diameter of the semicircle of this semicircle that is actually AB and 2 times the radius of this semicircle equals to 25 units. Okay, so now I will summarize the lecture. We actually wanted to find out the diameter of this semicircle that is AB, or the size of AB. We know that chord AD equals to 7 units in its size. Chord DC equals to 15 units in its size, and chord CB of this semicircle equals to 15 units in its size. And we want to find out the diameter of this semicircle. Okay, so first of all we made a construction. We connected together points B and D by a straight line. And we created angle ADB. Actually, angle ADB equals to 90 degrees according to rule number 1 that states that peripheral angle resting on the diameter of the circle is equal to 90 degrees. Okay, so actually, as you can see from the drawing, the peripheral angle ADB rests on the diameter of this semicircle that is AB, according to what is given us in the question. So angle ADB rests on AB, that is the diameter of this semicircle. Therefore, according to rule number 1 that states that peripheral angle that rests on the diameter of the circle equals to 90 degrees, this angle ADB that rests on the diameter of this semicircle equals to 90 degrees according to rule number 1. Okay, so angle ADB that rests on the diameter of this semicircle equals to 90 degrees according to rule number 1. Then we defined the center of this semicircle as point O, and then we connected together points O and C by a straight line, and we also connected together points O and D by a straight line. Then we focused on the green triangle and the orange triangle. On those two triangles, side DC of the green triangle equals to side CB of the orange triangle, and also DO equals to OB, because both DO and OB are the radiuses of this semicircle, therefore they are equal to each other, and OC is a common side, that is to say it belongs to both triangles, to the green triangle and also to the orange triangle, therefore OC equals to OC. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, those two triangles, the orange triangle is congruent to the orange triangle, the green triangle is congruent to the orange triangle according to side rule. Okay? So from the fact that those two triangles are congruent to each other, we can deduce that those two angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So we define one angle as alpha, so the other angle that equals to this angle also must be equal to alpha. Okay, so angle OCD equals to angle DCB equals to alpha, and then we focused on triangle DCB, on this triangle DCB. On this triangle, side BC of triangle DCB equals to side DC. Side DC of triangle DCB equals to side CB. Both those two sides are equal to 15 units. It is given us in the question, and we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So we have here two sides that are equal to each other, and according to rule number 2, in front of these equal sides there are equal angles. That is to say, those two angles are also equal to each other because they are located in front of those equal sides. Okay, according to rule number 2, those angles are also equal to each other, and if we name one angle as theta, then the other angle also must be equal to theta. So the size of those two angles are theta. Then we focused on triangle CDB, on triangle CDE, the green triangle, and the orange triangle CEB. On those two triangles, CD equals to CB equals to 15 units, and also CE is a common side, it belongs to both triangles, so CE equals to CE, and those two angles are also equal to each other, both of them are equal to alpha. So we actually proved that triangle DEC, the green triangle, is congruent to the orange triangle, triangle CEB, according to side angle side rule. If you prove that two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then you actually proved that those two triangles are congruent to each other. So we proved that those two triangles congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that angle DCE equals to angle DCE equals to angle CEB. Those two angles are equal to each other. Angle DEC is equal to angle BEC. Those two angles are equal to each other. Then we defined one of the angles as x, so if one angle is equal to x, the other angle must also be equal to x because those two angles are equal to each other. So we have two angles that both of them are equal to x. Those two angles are equal to x, and then we know that DB is a straight line because we connected points D and B by a straight line. So DB is a straight line, and we know that along a straight line at one side, at a certain point, the sum of the angles are equal to 180 degrees. So from one side, angle DEB, this angle DEB is equal to 180 degrees. But from the other side, angle DEB equals to x plus x. That is to say, equals to 2x. So we have this equality that states that from one side, angle DEB equals to 180 degrees, and from the other side, it equals to 2x. So from this equality, we can deduce that 2x equals to 180 degrees. Then we divided this equality by 2, and we got that x equals to 90 degrees. Okay, angle x equals to 90 degrees. So this is a right angle, and this angle that equals to x also equals to 90 degrees. It is a right angle. So those two angles are right angles. Then we know that chord OC is the radius of this semicircle because of the fact that it starts from the center of the semicircle and ends at point C, that is a point on the circle itself. Therefore OC is the radius of this semicircle. As radius, it must be a straight line. So OC is a straight line. OC is a straight line. So if we focus at point E on the right side of the straight line OC, the sum of the angles along straight line OC on the right side at point E must be equal to 180 degrees. Okay, so the sum of the angles in the right side at point E along the straight line OC equals to 180 degrees. But we know that this angle is a right angle, so 90 degrees plus angle OEB will be equal to 180 degrees. So we have this equality that states that 90 degrees plus angle OEB equals to 180 degrees, because that is the rule, that if we focus at a certain point and at one side of a straight line, then the sum of the angles is 180 degrees. So we got this equality that states that 90 degrees plus angle OEB equals to 180 degrees. Here we subtracted from this equality 90 degrees, and we got that angle OEB equals to 90 degrees. Angle OEB equals to 90 degrees. This angle is a right angle. So we actually found out that three angles around this point E are right angles. And the sum of three right angles is 90 degrees times 3 is 270 degrees. So we know that around point E we have three angles that the sum of them is 270 degrees. And we have rule number 3 that states that the sum of the angles around a point is equal to 360 degrees. Okay? The sum of the angles around a point is equal to 360 degrees. Okay? So, actually, the sum of the angles around point E is equal to 360 degrees. So, we can write the equality that states that the sum of the angles around point E is 360 degrees, and we have three right angles that the sum of them is 270 degrees, plus the value of the fourth angle that we defined as Y. This angle is defined as Y. The sum of those four angles around point E is equal to 360 degrees according to rule number 3. So from this equality we can subtract 270 degrees, and we found out that angle Y equals to 90 degrees. So the fourth angle is also a right angle. So we found out that all the angles around point E, all the four angles, are right angles. They are equal to 90 degrees. Okay, then we focused on two triangles, on triangle ADB and the small triangle, triangle OEB. We know that those two angles are right angles, therefore they are equal to each other. And those two triangles we have a common angle, therefore angle B equals to angle B. Angle B belongs to the big triangle, triangle ADB, and angle B belongs also to the small triangle, triangle OEB. So we have the second angle that equal in those two triangles, and the third angle, angle DAB, will be also equal to this angle, angle EOB, according to third angle theorem. The third angle theorem states that if you have two triangles that are equal between them in two angles, then they also must be equal between them in the third pair of angles, because the third pair of angles is complementary to 180 degrees. So in this way we prove that all the angles in the big triangle of triangle ADB are equal to all the angles in the small triangle, triangle OEB. From the fact that those two angles, those two triangles are similar triangle, according to angle rule, we can deduce that the following relationship exists between the sides of those two similar triangles. According to the rule is OB over AB equals to OE over AD. Okay? Again, OB over AB equals to OE over AD. Because of the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two triangles. So we know that OB equals to R, and AB is the diameter of the circle, of the semicircle, therefore it equals to 2R, and AD equals to 7 units. So in total we got this equality, R is cancelled here, and we got that OE equals to 7 over 2 units, and then EC equals to OC minus OE. So EC equals to OC, that is the radius of the semicircle, minus OE equals to 7 over 2. So in total EC equals to OC, to R minus 7 over 2, and we have already found out that OE equals to 7 over 2. Then integrate two triangles, we have two right triangles. In the orange triangles, triangle CEB is a right triangle because angle CEB is a right angle, and triangle OEB is a right angle because angle OEB is a right angle. So we have here two right triangles. So we can, and we know that EB is a common side. It belongs to both the right triangle, triangle OEB, and EB also belongs to the right triangle, triangle CEB. So we created the statement that said that EB square equals to EB square, and then we implemented the Pythagorean theorem on the right triangle, triangle EOB, on the right triangle, triangle EOB, EB square equals to OB square minus OE square. EB square equals to OB square minus OE square. And the second EB square is related to this right triangle because EB belongs also to this right triangle. Here EB square will be equal to CB square minus CE square. Okay? EB square equals to CB square minus CE square. But we know that OB equals to R, OE equals to 7 over 2, and CB equals to 14 units, and EC equals to R minus 7 over 2. Okay, so we have only one variable here. Actually, after we solve this equality, we arrived to a quadratic equation. We arrived to this quadratic equation: 2r squared minus 7r minus 225 equals to 0. The coefficients of this quadratic equation are a equals to 2, b equals to minus 7, and c equals to minus 225. And the variable of this quadratic equation is r. So we solve this quadratic equation according to the special formula. Again, x equals to r, and we found out the values of a, b, and c. A equals to 2, b equals to minus 7, c equals to 225. So we solve this quadratic equation. The only thing that is left is to put all the data inside this equation equality. We solved this equality and we found out that the radius of the semicircle equals to 12.5. We have another solution that the radius equals to minus 9, but the radius cannot be a negative number, it must be a positive number, so this answer is not correct, and we left only with the answer that the radius of the semicircle is 12.5 units. Therefore, the diameter of the semicircle that equals to AB is 2 times the radius, 2 times 12.5. That is actually 25 units. So we found out that the diameter of this semicircle is 25 units. Again, the diameter, that is 2 times the radius, and it is also equals to AB, is equal to 25 units. Okay, thank you very much.